and in this video, we're going to make a buffer solution using a weak acid and its conjugate base. For this experiment, we're going to need some equipment. Because we're making a solution, we'll be using a 100 milliliter volumetric flask. We will be adding small increments of the conjugate base, and we will add a known amount of the weak acid, so we will be using a scale. For mass measurements, we always need a weighing boat and a spatula. For our chemicals, we're going to need the weak acid. Today, for me, that will be the benzoic acid, but you can use any acid, including acids that are available in the form of solutions or stock solutions. And here I have my conjugate base. Today I will be using benzoic acid as my weak acid and sodium benzoate as its conjugate base. I will also need some deionized water. I will be using a large beaker to contain my waste. I will need a pH probe and a connected device, which for today will be my iPad. And I already calibrated my pH probe and connected it to my device. Because I want to make sure that I do not exceed the 100 milliliter mark on my volumetric flask, I will be using a pipette with a bulb to make sure that the volume is accurate. And finally, every time I am recording a pH measurement, I will need to extract the pH probe, rinse it with deionized water, and dry it with a Kim wipe. So I will need some Kim wipes and a squirt bottle with deionized water. Let's get started. First, I am going to turn on my scale, place a weighing boat on top, tare it, and then I will measure 0.30 grams of benzoic acid. I have just a little bit more. It is 0.31 grams. I will take this and transfer it carefully into my volumetric flask. I can place my weighing boat back on the scale, and it confirms that I transferred all 0.31 grams of my benzoic acid into the volumetric flask. With that, I discard of my used weighing boat. Then I will add small increments of deionized water. Swirl my solution so it dissolves. If it looks like it does not dissolve any further, we add more of our deionized water. Benzoic acid is only sparingly soluble in water. Therefore, before we start moving into the water additions that approach the neck of the volumetric flask, we need to make sure that we dissolve as much as possible through vigorous shaking and swirling. My acid appears dissolved in the water, mostly. So I will add another small increment of water and shake it again. Now we are ready to fill the contents of this volumetric flask all the way to the mark. And as I'm getting closer to the 100 milliliter mark, I will switch to the addition of water with a pipette. Now it's becoming a little bit more clear that some of the acid didn't fully dissolve. This is the part where we can try again. Swirl the contents of our solutions back and forth. And if it is still not dissolving, it is a good time to switch to a hot plate to make sure that it's fully dissolved before we can move on to the addition of the conjugate base. Now that our benzoic acid is fully dissolved in the water, we have a 100 milliliter solution. Based on the mass of the benzoic acid we put in the water, we can determine the molarity of this solution. And that gives us the molarity of the acid in the solution. Now I will take my solution and transfer it into a 150 milliliter beaker, simply because I cannot squeeze my pH probe inside a 100 milliliter volumetric flask neck because this is too thin to hold the pH probe. Therefore, from now on, I will be doing my measurements inside the beaker. So I am done with the volumetric flask. Next, I can add a drop or two of universal indicator to get an estimate of my pH. And with 2 drops in this optional step, I find that the color is more of an orange, and that means we have a relatively acidic pH. But to know the exact pH of my weak acid solution, I will need to submerge a pH probe into it. I will extract my pH probe from its container, rinse it with lots of deionized water, and then wipe it with a Kim wipe. Once it is ready, I submerge it into my weak acid solution and record the starting pH of the solution. This will take approximately 30 to 40 seconds. The pH of my weak acid solution is 2.89. And with that, for the time being, I am done with my pH probe. I will rinse it off, wipe it, and place it back into its container. Now let's remind ourselves, a buffer is a mixture that will contain both a weak acid and its conjugate base. We already put the weak acid in there, which was the benzoic acid. Now we're going to add its conjugate base, which is the sodium benzoate. We're going to add it in small increments, and we're going to observe over time how the pH of the created buffer is going to differ from its original weak acid solution. So we'll start by placing a weighing boat on the scale, tearing it, and then measuring 0.1 grams of sodium benzoate. My first measurement is 0.11 grams of sodium benzoate. Next, I will take this and transfer it into my beaker. It will need to be stirred until the sodium benzoate is fully dissolved. For the stirring, I will be using a stirring rod. Sodium benzoate is substantially more soluble than benzoic acid. But we still have to wait until the sodium benzoate is fully dissolved, and we already start seeing a slight color change in the universal indicator. Next, we're going to take our pH probe and confirm that there has indeed been a change in the pH. We extract it from the storage solution, rinse it thoroughly with water, wipe it, and submerge it into our solution. And then we give about 20 to 30 seconds at least and record our pH. The pH of our solution is 3.76. And with that, we have completed the first addition of sodium benzoate. Next, we rinse the pH probe and set it back. We measure another 0.1 gram of sodium benzoate. The second measurement is 0.13 grams. We add this to our solution. And we stir again until all the sodium benzoate is fully dissolved. We have not reached our solubility limit yet. With all the sodium benzoate fully dissolved, we are ready to record the pH of our buffer. The pH of our buffer is 4.31. We find that the pH of the solution is 4.52. So the change in pH has slowed down significantly. Let's add one more increment and see if it is going to change meaningfully after this. I measured 0.12 grams of sodium benzoate. We will attempt to dissolve all of this. Now that it is fully dissolved, we are going to record the pH. The pH now is 4.62. So this is where we can stop the experiment. It is equally easy to perform this experiment with another weak acid and its conjugate base. Just be mindful that the concentration of the initial acid may be calculated differently if your original weak acid is not a solid, but rather available as a concentrated stock solution. With these skills, you should be able to perform on your own the preparation of a buffer solution of any pH by selecting the appropriate weak acid and creating the appropriate ratio of acid to its conjugate base. Now, when you are ready with your experiment, then your next task would be testing your buffer. And you can do that by splitting your buffer into two beakers. That way you ensure that it is the same buffer with the same pH. And at that point, you can add a few drops of acid and a few drops of base on the individual beakers. That way, you will be able to test your buffer's ability to resist changes in pH as a response to acid or base attacks.